Okay, here's some information that will hopefully help you with the logarithm basics of logarithms assignments or intro to logarithms. Okay, so just a little bit about what a logarithm is. Um, you can write this particular logarithm. Well, this is telling how to write a logarithm. This is the way it's written, and it's read log to the base 2 of x equal 3. Log to the base 2 of x equal 3. If a base is not written, it's understood to be 10. Notice how this has a little 2 there, but if you would just see something that was like log x, what that's saying is the base is 10. It's kind of like when you're doing square roots, they don't always put the 2 outside the square root symbol. It's understood. Well, the base that's understood with logarithms is 10. If it says ln instead of log, then it is a logarithm with base e. So the ln of x is the same thing as log base e of x. So the base is e. And e is a number that occurs in science frequently. It's an irrational number. It's kind of like pi in that it is a non-terminating, non-repeating decimal number, so that's why the symbol is written as opposed to a decimal approximation for it, just like with pi, but sometimes we do substitute decimal approximations for it. It's 2 point something, and then, yeah, that's all you really need to know about it right now. Okay, and then the domain of the base of a logarithm is 0 to infinity. In other words, you cannot have a negative base, and it can also not be 0. The base of the logarithm, that's the little number that's written down there, right there. You can't have a 0 there, you can't have a negative there. Okay, so going on, how to write a logarithm as an exponential equation. Okay, so the definition of the logarithm, it sometimes is called, or the conversion formula, log to the base b of y equals x. It doesn't really matter where you put the x and the y, as long as you know what things go where. B is the base, the number that's written small is the base, the number on the side by itself is the exponent, and the thing that's here is that. And so this would be written 4 to the second power equals 16. There isn't anything to solve for there, it's just making a statement. And so sometimes it's called rewriting from one form to the other. So like if you're in log form, you can go to exponent form. If you're in exponent form, you can go to back to log form. And part of your assignment does just that, has you do some rewriting. So the base is 6, the exponent is 4, and this is what it's equal to. The base is not written, so it's 10. This is the exponent, and so that would be the rewrite. This would be the base of 3, exponents on the side by itself equals that. We're just rewriting. Remember here the base is e, even though it's not written. So this would be e to the second power equals 7.389. Okay, and then you can go the other way around. You can go from the exponent form back to the log form. So you would be writing log. The base is what goes down here, 2. The exponent is what goes on the side by itself. And then the other number goes there. Exponent's always on the side by itself. So this would be log to the base 2 of 32 equal 5. And with e, it's ln. ln, and then the exponent is what goes on the side by itself. The ln of x equal 3. The log to the base 5 of 125 equal 3. The exponent's on the side by itself. Log to the base 7 of 343 is 3. Okay, so that's how that works. These problems just kind of bring back to mind some properties of exponents that you've had in the past that you may have forgotten. Most of you probably had in Algebra 2. Some you may have also had in Algebra 1. The idea of the negative exponent, remember, you just make it into the reciprocal and give it the positive exponent. And of course, you could go ahead and simplify that. And then something like this, you would rewrite it in radical form. The 1/2 power is the same thing as the square root. The bottom number gives you the index on the radical. The top number in the fractional exponent gives you what to put there. And then, of course, you'd go ahead and simplify. And we could have gone ahead and simplified that one as well. Okay, and then this one would be similar, except we've got both the negative exponent and the fraction. So now it's going to be 1 over the square root of 36, which would be 1/6. Here, anything to the 0 power is equal to 1. Anything to the first power is just equal to itself. Okay, on to the next page. These are some logarithmic expressions that you should be able to do without a calculator. And so, for the most part, there might be a couple that you would need. So you just would need to use the conversion. So you would do like 3 to the x equals 27. And then you probably know that if you raise 3 to the third power, you get 27. And then just think about that being equal to x. 2 to the x equals 128. That one you probably don't necessarily know. It's a pretty big number. It's to the 7th power. Whenever the base and this number match, remember the exponent would just be a 1. You could rewrite it as the x power equals 8, and then, of course, the x would be 1. Log to the base 4. Anytime there's a 1 here, remember what the answer would be. Or to the x equal 1, in order to get a 1, you have to raise it to the 0 power. Anything to the 0 power is 1. Any base to the 0 power is 1. The ln of e, they're kind of like inverse functions. So remember, this ln was the same as log with the base e of e, which then kind of turns it back into something like this, where these match. So e to the x power equals e. X would have to be 1. This would be 3 to the x power equals 1/27. Anytime you have a whole number on one side and a fraction on the other, you know the exponent's going to be negative, because that's how you switch from whole numbers to fractions. And then you just have to think 3 raised to what power is 27? Here we've got 1/2 to the x power equals 1. You get an answer of 1. The exponent had to be 0. This is kind of the same thing. It's just a different base. It's going to be 0. This one, remember, if the base isn't written, it's 10. So we'd have 10 to the x equal 100. You can probably tell by looking, you'd have to square 10 to get 100. 5 to the x equals 1 over 25. Well, whole number fraction, we know the answer is going to be negative, and then 5 squared to get 25. This one maybe is a little bit more tricky. This base raised to that exponent equals this number. They're both fractions, but notice that they're reciprocals of each other. So that means the exponent was -1. This is a base of 10. 10 to the x equals 1 over 10,000. Again, whole number fraction. So we know it's going to be a negative. How many zeros? 4. And that's it. Okay. These are a little bit different. These are finding logarithms with a calculator. And so here you do want to use your calculator. And all you'll do is just plug these numbers into the calculator. Make sure you know where the log button is and the ln button is. And then you can just do those on your calculator. So you should get 0.093. You do have to round to 3 decimal places. So remember, you look at the 4th decimal. If it's 5 or bigger, you bump up the number before it. If it's less than 5, you just cut it off after the 3rd number. Okay, and then so this one would be 1.827. This one is 1.792. And this one is not possible. You cannot take the logarithm of a negative number. In logarithms, you can't have a negative here, and you can't have a negative base. You can have a negative exponent that it's equal to, but you can't have a negative there or there. Okay. What about logs that aren't base 10? Well, a lot of calculators now have a function where you can do logarithms with different bases. And so then this really isn't important. But if you have a calculator where you cannot, there is something called a change of base formula. And what you can do is you can change these from other bases to a log with base 10 so that you can use your calculator. So the way it works is I could write it with letters. Log to the base b of m equals common log of m over common log, which has base 10 of b. So notice I just took the log of the number that's written big divided by the log of the number that's written smaller. And that's it. You can also do LNs if you want, because you usually have that key on your calculator as well, but a lot of times the common log is what's used. Okay, and so then you could either leave it this way if your calculator does those kind, but if not, and you had to use the change of base formula, it would be log of 10 over log of 4. This would be log of 25 over log of 2. This would be log of 19 over log of 3. Notice that those are all common logs. They all had base 10. All right. Is that all? Guess. Yeah, I guess that's it. Okay, so that should help you with those problems then. All right. Okay. Best wishes.